This is going to be a review of factoring rules. So when you're factoring polynomials, the first thing you should always try to do is see if you can factor out a greatest common factor, or a GCF. Then, if you have a binomial, check if it's a difference of squares. And next time we'll even look at possibly whether it's a sum or difference of cubes. If it's a difference of squares, so something like a squared minus b squared, it would factor to a plus b times a minus b. If you have a trinomial, check if it's a perfect square. For example, a squared plus 2ab plus b squared factors to the quantity a plus b squared. And a squared minus 2ab plus b squared factors to the quantity a minus b squared. If you have a trinomial that's not a perfect square, but it's of the form x squared plus bx plus c, in other words, our a is equal to 1, use the sum and product method, and I use an x to help organize that method. And here, so something that's of the form x squared plus p plus q times x plus pq factors to the product of x plus p and x plus q. Finally, if it's a binomial of the form ax squared plus bx plus c, where a does not equal 1, then we'll use factoring by grouping, or the Xbox method, which is a way of organizing factoring by grouping. There are other ways of doing this, but I have found that these are the simplest ways if you're struggling with factoring. Also, you could use factoring by grouping if you have 4 terms. So in this video, we're going to look specifically at factoring out a GCF, a greatest common factor, factoring a trinomial of the form where we have a equal to 1, and factoring, oops, I put binomial, didn't I? Factoring a trinomial, correct that, of the form where a is not equal to 1. Okay, so first we're going to look at factoring out a greatest common factor. So the steps are generally determine the greatest common factor, so the largest term that divides evenly out of all the terms in your expression, and then divide out the greatest common factor from each of those terms. So for example, 16x squared minus 12x. So our GCF, if we look at 16 and 12, the largest number we can divide out of both of those is 4. And they both have an x, and my lowest exponent is a 1 that is in the 12x. So 4x is my GCF. Okay, so I will now divide 4x out of both the terms 16x squared and minus 12x. 16x squared divided by 4x is 4x. Negative 12x divided by 4x is negative 3. So this factors to 4x times the quantity 4x minus 3. 18x to the 6 minus 12x cubed minus 3x squared. Our GCF here, if we look at 18, 12, and 3, would be 3. I would write down my x, and the lowest exponent I see on an x is 2, so 3x squared becomes my GCF. Now dividing all my terms by 3x squared, 18x to the 6 divided by 3x squared is 6x to the 4th. Negative 12x cubed divided by 3x squared is negative 4x. And negative 3x squared divided by 3x squared is minus 1, negative 1. So this factored to 3x squared times the quantity 6x to the 4th minus 4x minus 1. Let's look at one more example. 25x squared y cubed plus 15x to the fourth y to the fourth. My GCF, if I look at 25 and 15, is 5. Both the terms have an x term in it, and my lowest exponent is the 2, so x squared factors out. Both terms have a y term in it, so I write down the y, and my lowest exponent on the y is cubed, so y cubed factors out. So my GCF is 5x squared y cubed. Now I need to divide that out of all my terms. 25x squared y cubed divided by 5x squared y cubed is 5, plus 15x to the fourth y to the fourth divided by 5x squared y cubed is 3x squared y. Okay, so now let's look at factoring trinomials where a is equal to 1, or we do not have a coefficient in front of the x squared. So we're going to draw an x, and what we will do is we'll put our c term, our constant, at the top of the x, our b term, which is the coefficient of x, at the bottom of our x, and then we will look for numbers p and q that multiply to c but add to b. So in my first example, my c term is negative 21, so that goes at the top of my x. My b term is 4, that goes at the bottom. And I need two numbers that multiply to negative 21 but add to 4. Those would be 7 and negative 3. 7 times negative 3 is negative 21. 7 plus negative 3 is 4. So my factors will be x plus 7 and x minus 3. I just take the 7 and negative 3 and put it in my parentheses with my x. Let's look at example B. My c term is 8. My b term, which is the coefficient of x, is 6. Two numbers that multiply to 8 but add to 6 are 2 and 4. So then I will write in parentheses x plus 2, x plus 4, and that is our b example factored. Our last one. Now, if we recognize that this is a difference of squares, we could factor it that way, but let's factor it using the x method. So negative 9 is my c term. It goes at the top. I don't have an x term, a linear term, so b is 0. And I need two numbers that multiply to negative 9 but add to 0. Negative 3, positive 3. So I can write my factors as x minus 3 times x plus 3. So that is the x method. Now, let's look at examples of factoring where we have a trinomial and our a term is not equal to 1. So in general, we're going to put the product of a times c at the top of our x. And b will always go at the bottom. And then we will look for two numbers, again, that multiply to my top, my a times c, but add up to my bottom, my b term. And then we will place those factors, or those numbers from the x, into a box in certain places. And we will factor using a greatest common factor. So my first term, my ax squared term, will always go in the top left box in my box. My c term will always go in the bottom right. And those question mark numbers that multiply to the product ac and added up to b will go in those empty squares in my box. And it doesn't matter which one goes where. So let's look at that with an example. And just a reminder, whenever you're factoring, you should still always look for a GCF first. So in my example A, 2x squared minus 5x minus 12, there is no GCF. There's no greatest common factor. So now I take a times c, 2 times negative 12, and get negative 24. That goes at the top of my x. And the b term, negative 5, goes at the bottom. I can start filling in my box. So my first term, 2x squared, goes at the top left. The last term, negative 12, goes in the bottom right. Now I need two numbers that multiply to negative 24 and add to negative 5. Those would be negative 8 and positive 3. And I am going to use those terms along with an x to fill in those empty boxes in my box. And it doesn't matter which one you put where, we'll get different answers in the middle, but the final answer will be the same. I'm going to put my negative x down here and my positive 3x right here. Now I'm going to look at each row. If I look at this first row, what is my GCF? 2 and 3. I can't factor any other number besides 1, but both of these terms have an x, so I can factor out an x. My second row, negative 8, negative 12. If I look at the number part, I can factor out a 4. They don't both have an x, so I cannot factor out an x. But because the left one is negative, I do want to factor out my negative. I could do the same thing with the columns, but sometimes it's easier to think x times what is 2x squared if I'm looking at my first row? 2x. X times what is 3x? 3. I could check it with my bottom row. Negative 4 times 2x gave me my negative 8x. Negative 4 times 3 gave me my negative 12. You might recognize this if you learn to multiply polynomials with a box. But now I have my factors. X minus 4 is one factor, and 2x plus 3 is my other factor. So A factors 2x minus 4 times 2x plus 3. Let's repeat this process for the B example. So if I look for GCF, 9, 6, and negative 24, I can factor a 3 out of everything. I cannot factor an x out of everything, so my GCF is 3. Let's factor that out. I'll write 3, and then 9x squared divided by 3 is 3x squared. 6x divided by 3 is 2x. Negative 24 divided by 3 is negative 8. Now I'm going to look at my A is 3, and my C is negative 8, and my B will be 2. I'm going to use those for setting up my x box. 3 times negative 8 is negative 24. That goes at the top of my x. B, which is 2, goes at the bottom. I can fill in my box using the first term, which is 3x squared. The bottom right of the box will be negative 8. And I am looking for numbers that multiply to negative 24, but add to 2. 6 and negative 4. 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2. I'm going to fill in my box with those terms with x's. I'm going to put my 6x here and my negative 4x here. But again, if you swap them up, you would get the same final answer. Looking at my first row, looking for a GCF, 3 and 6, I can factor out a 3, and they both have an x. So 3x is my GCF. In my bottom row, 4 and 8, I can factor 4 out of both. My left term is negative, so I will factor out a negative 4. If I look at my top row, 3x times what is 3x squared? I would get x. 3x times what is 6x? I would get 2. And we have our factors. So one is 3x minus 4. The other factor is x plus 2. So factored, so far I have 3x minus 4 times x plus 2. But I need to remember I factored out a greatest common factor. That comes down and goes in front. So this is my final factorization. 3 times the quantity 3x minus 4 times the quantity x plus 2.